Try chapter test number 117. This is from the textbook, the back of the chapter. I'm going to start it for you, and then if you want, pause the video, work on it on your own, and then come back and we'll go over it together. Suppose the systolic blood pressure for an adult male above age 55 is normally distributed. So I see the words normally distributed, and I know I've got the normal bell curve, with a mean of 145 and a standard deviation of 20. So when provided with problems involving the bell curve, you also must be provided with the mean and standard deviation. If a 60-year-old man is selected at random, find the probability that his blood pressure is between 140 and 160, greater than 170, and then we have a part C that says if 4,000 adult males above age 55 have their blood pressure checked, how many would you expect to have blood pressures less than 130? Okay, so notice that the use of the ages for the men, adult males above age 55, is not this number of 55 does not come into play in this problem. The fact that it's provided to you here may throw you, but it's simply a way of basically preparing the study at hand. We want to make sure that the group of people that we're working with are all generally the same age. So this is basically for consistency, that you're dealing with people that are generally all over 55 and you're not dealing with kids or young adults. So it's just a matter of putting people into the same age bracket. It has no bearing on the problem. So the fact that this man is 60 means nothing. Okay? The numbers that are important are the mean of 145, the standard deviation of 20, the raw scores that are put on the horizontal axis, 140, 160, 170, and in this case 130. And for part C, you also have to make use of the fact that you've got a total of 4,000 adults. Okay, so if you want, try this one on your own, and you're going to get basically a proportion of area for part A, a proportion of area for part B, and for part C, you're being asked not for a proportion of area, but how many of the 4,000 adult males you would expect to have blood pressures less than 130. So you're asked for a number of people, not a proportion. Okay, and there's one more part to this question. Volunteers from a Red Cross mobile unit that is checking blood pressures decides to recommend for additional medical diagnosis only those men above age 55 whose blood pressures are at the third quartile or greater. What would be the minimum systolic blood pressure required to be recommended for additional medical diagnosis? So this question is a little bit different than the other three, but generally it's using you have to make use of the same mean, the same standard deviation. Okay, so let's go over these questions. A blood pressure between 140 and 160, you're basically going to set the lower on your calculator's normal CDF to 140, the upper to 160, the mean is 145, and the standard deviation is 20. The question is asking you for let's see, the wording of the question says again, find the probability. So that is basically a normal CDF question. So when you do parts A and B, you're finding probability, which is a normal CDF question. So you will use normal CDF on your calculator. So we're going to enter a lower of 140, upper 160, mean of 145, standard deviation of 20, and you'll get a value 0.3721, 37.21%. Okay, so the probability that a person has blood pressure between 140 and 160, 37.21%. The probability that a person have blood pressure greater than 170. So it's similar because we're still using normal CDF, but instead of finding the area between two finite values like letter A has, between 140 and 160, greater than 170 means that we're going to find the area from 170 all the way up, because it says greater, up to positive infinity. So when we use normal CDF on our calculator, the lower is 170 and the upper is positive 100,000 to represent positive infinity. The mean is 145 and the standard deviation is 20. Again, the same mean and the same standard deviation. So we enter that into our calculator. That will give us a proportion of area that's greater than 170 or to the right of 170, and that comes out to be 10.56%. So the probability that a person or an adult male chosen at random has blood pressure greater than 170 is 10.56%. Part C. If 4,000 adult males above age 55 have their blood pressure checked, how many would you expect to have blood pressures less than 130? First, to answer the question, let's find the proportion of people with blood pressures less than 130. Remember, a proportion is basically a percent or a proportion of area. It could be expressed as a percent or it could be expressed as a decimal, but it's a number between 0 and 1 or 0 and 100%. After we find that percent or that proportion less than 130, then we could use that proportion, multiply it by our total number of adults, which is 4,000, and get the total out of 4,000 with blood pressures less than 130. Basically, the number out of the 4,000 that we would expect to have blood pressures less than 130. So I'm going to go to the calculator and demonstrate this. You're finding the proportion of area, so you use normal CDF. The question was less than 130. So less than 130 has a lower value of negative 100,000 because it's going all the way down to negative infinity. And upper of 130, standard deviation of 145, a mean of 145, a standard deviation of 20. Okay, and this is not the answer yet. 0.2266 is the proportion of area. 22.66% of people would have blood pressures less than 130, but that's not a number out of 4,000. To find the specific number out of 4,000, you take that proportion and you simply multiply it by 4,000. Okay, multiply it by 4,000. And you get a number 906.5, and if you just round this using normal rounding rules, it's 907 people. Okay, so 907 people out of the 4,000, you would expect their blood pressures to be less than 130. Okay, so 907 men. Okay, so now we're going to look at a slightly different question. Volunteers from a Red Cross mobile unit that is checking blood pressures decides to recommend for additional diagnosis only those men above age 55 whose blood pressures are at the third quartile or greater. Okay, so additional medical diagnosis would be provided for people with higher blood pressures. So the third quartile which we remember from chapter 3 is basically the 75th percentile, represents, well, maybe let's make a picture. If we make a bell curve, let's see, do I have a bell curve here? Let's look at a previous image of a bell curve. Okay, so this shaded area, disregard it for the moment, but let's remember that the quartiles basically break off the bottom 25%, then the bottom 50%, then the bottom 75%. So the bottom 75% of area we could get that if we drew like a vertical line at approximately this point in the bell curve. And 75% of the area would be shaded to the left of that vertical line, are labeled on the horizontal axis. So if the 75th percentile is this blood pressure right here, the one that breaks off or cuts off the bottom 75% of area, then that's what we have to find. We have to find the bottom 70, we have to find the blood pressure that cuts off the bottom 75% of area. So to find a blood pressure, which is not an area and not a probability, is basically a raw score, we have to use IMV norm. Okay, because when IMV norm is used when we want to find a score on the horizontal axis. The third quartile is the same as the 75th percentile, so you're looking for the raw score that cuts off the bottom 75% of the bell curve. So in that other bell curve I just showed you, the 75% mark is basically, if I make a bell curve here, 75% would be somewhere at this point. 75% of the area would be all the area to the left, and we have to find that missing score that cuts off the bottom 75%. So this is exactly what you would use IMV norm for. The area to the left in IMV norm should be entered as 0.75. You enter the mean of 145 and the standard deviation of 20. And what you'll get when you hit enter is a raw score. Okay, 158. So let's do it and see if it works out. Second, DISTR. When we're asked to find a raw score, we use IMV norm. The area to the left of that raw score, because it says the third quartile, we know the area to the left is 75%. Mean stays at 145, standard deviation is 20. Paste it. Okay, and when rounded to the nearest whole number, it's 158. And like I said, if you ever have questions on how to round, usually the WebWork problems will always provide directions on that. Okay, the rest of this lecture